here we have page 331, question 16. So again, like in the previous video, use the video as a prompt to help you through the question. Don't just watch the whole thing through in one go. Try and attempt the question yourself first, and then use the video as a nudge to help you through the problem. So again, like the last time round, the best thing to do to begin is have a look at your diagram and see, are there any observations you can make about that diagram? So I'm looking particularly at those two triangles, QPS and QRS. So pause the video now for a while and see what you can come up with in relation to those. Okay, so I'm looking at this and I'm noticing that, okay, well, these two angles match and these two angles match. So that must mean that the third angle in each triangle matches. And I'm going to just note that in my diagram for myself visually first of all. And then I'm going to write down my statements that lead to that. So again, don't forget, every statement that I make, I need to give a reason to go with it. So I'm going to say, well, the angle PQS equals to the angle SQR. That's these two guys in green here. The reason for that is I'm told it in the question, so I can just say given. And I can make the same observation about these two angles up here. The angle PSQ equals to the angle QSR. That's also given. And so I'm using those two statements then to work towards the idea that these two angles are equal. So I'm going to say that implies the angle QPS equals to the angle QRS. Now I'd like to give a reason for that too. And the reason is, what do you think it is? It's that it's the third angle in the triangles. Okay, so the third angle must be equal if the first two pairs of angles were equal. So if that's the case, you can see that I've been able to mark them in the same way in the diagram. Now let's have a look back to our diagram again. So we've looked at it from the point of view of the two separate triangles, but now could we look at it from the point of view of the whole diagram? So instead of having two separate triangles, let's think about this shape here. So this shape, what's it called again? It's called a cyclic quadrilateral. And we have a theorem relating to the cyclic quadrilateral. So go and think about that theorem. What were the rules in that theorem? And then how can we apply them? Well, that theorem stated that the opposite angles in a cyclic quadrilateral add up to 180. So I'd like to write that down as a statement. And I'm thinking of focusing particularly on these two angles here because they're relevant to what I'm trying to prove. So it's kind of hard to write that down with just symbols marked in. So I'm going to put in X and X in my diagram. So I'm going to say, okay, well, X plus X equals to 180 degrees. So that means 2X equals to 180 degrees. So from that, I can work out the value of X. X equals to 180 over 2. That means X is 90 degrees. Sorry, can I just go back there for a second and again give a reason? I've made the statement, I haven't backed it up. So X plus X equals 180. What reason should I give, do you think? Okay, so opposite angles in a cyclic quadrilateral. I'll abbreviate there to cyclic quad. Okay, so if X is 90, well, what was my goal to begin with? My goal was to prove that QPS is 90. Now look, the angle QPS is one of the angles that I called X. So I'm going to say, but the angle QPS equals to X. So therefore, the angle QPS equals to 90 degrees. Again, notice how my final line of a proving question is always a statement of what it was that I was asked to prove.